Everybody, welcome back to another fun and exciting Algebra 1 class. Today I'm going to begin the class with a magic trick, okay? Now, maybe this would be better said that it's going to be a mathic trick. You see what I did there? Mathic, not magic. All right, well, we'll see if you like it. Maybe you will. Maybe you'll like, oh, come on, that was boring. All right, let's look at this. So, look down at the screen, and I have 64 divided by 2. Okay? 64 divided by 2 equals what? Well, some of you are like, I don't know. All right, well, put it into your calculator and figure it out. All right, obviously, the other thing that you could do is 64 divided by 2. Okay, and that goes 3 times 6, 0, bring down the 4, 32. It goes 32 times. Okay? Now, we did that the traditional method, the traditional way. Some of you did it in your head. Some of you had to use your calculator. Okay. But we got the same answer. We got 32. Now, let me show you. Here's the that wasn't the magic trick. Okay. Here's the magic trick. What about this? What if I do this a different way? What if I say I don't want to do it that way anymore? I want to do this a different way. All right, so here's kind of the new method. Here's the that wasn't the magic trick, by the way. Okay, this is the magic trick. What if I take this and I divide this fraction and I divide them both by 2? So I have 6 divided by 2 and 4 divided by 2. What do you think is going to happen? Well, remember, what was the answer? The answer was 32. Okay, so now watch this. 6 divided by 2 equals 3. 4 divided by 2 equals 2. Wow, Mr. Steve, that was awesome. I know. That was a magic trick and you enjoyed it, okay? Some of you are like, I'm falling asleep right now. You're boring me. No, I'm trying not to bore you, okay? But really, okay, that was a mathic trick, not a magic trick. But some of you didn't even know that you could do that. You didn't even know that was a thing, all right? And it works with any number. I mean, you could throw 104, okay, if divided by 2. If we cut it like this and we do 10 divided by 2 and 4 divided by 2, we get 52, okay? And you can do any number like that. And it's kind of just a trick. Well, we're going to utilize that trick here. So let's go ahead and look in your book on page 203, dividing a polynomial by a monomial. We're going to use that same trick right here. We're going to cut this polynomial and we're going to take this monomial on the bottom and we're going to divide each one separately by the 2x. In other words, we're going to make them into like 3 separate fractions right here. Okay? Now, do it a couple different ways. You can think of it that way, or you could also think of it like kind of like more like regular traditional division, and you're dividing everything by 2x. Well, how did we do that in traditional division? Well, in traditional division, if we divided 2 into 64, go back to that first example that we looked at, we really did divide these, didn't we? Yeah, because we just did the 2 into the 6 first. That's right. And so there was a division going on of those numbers. Well, really what happens here is if we divide into that, then we divide into that, then we divide into that. So you can kind of look at it a couple different ways, but this is the way that I want you really to view it right now, is that you are making 3, 4, 5, however many terms you have, separate fractions. Okay, so what is this going to equal? Well, let's just take it piece by piece. What does the first one equal? Well, that gives you cancel, cancel. That gives you 4 in the top. 5 minus 1 is x to the 4th. So we have x to the 4th. And then this is all going to be over whatever we get. So there's a 1 times, and then times again, because we have 3 different things in the bottom. Notice a couple things there. Everything canceled in the bottom, so I really don't even need to write that 1 over there. I'll write it just so you can see it right now. Notice that actually had a 1 in it, so we subtracted 5 minus 1 to get 4. Okay. And notice that the bigger one was on top, so it stays on the top. This is some of the lessons that we learned in the last lesson that we did, 6.9. All right. Now we'll go over here to the second one. Also, don't forget about that plus sign. We're going to want to put that plus sign right there. That's important. Okay, and so then we've got this one, and again we cancel 1, cancel to a 2. That's a 1, so that's going to cancel to a 1. This is going to cancel to an x cubed. All right, so up in the top we have 2x cubed. Another plus sign, and then that canceled to a 1 in the bottom. Well, same thing here. That's going to cancel to a 1. That's going to cancel to a 1, and we're going to cancel this. 3 minus 1 is 2. So 3x squared, and that's a 1. So everything in the bottom is a 1. We don't need the 1 down there, so this would be our answer. 4x x to the fourth plus 2x cubed plus 3x squared. And that's in your book on page 203 if you want to follow along with that there. All right, next one. Also in your book. Let's do it again. We're just going to separate this. Where are we separating it? We're separating it at the plus and minus signs. So, x and x. Now, in this one, we're actually going to end up with a denominator. So sometimes you end up with just ones in the denominator. Sometimes you actually end up with a denominator. Well, really the only denominator you can end up with is the x, unless you have a negative exponent that's going to flip down into the denominator. But we don't know what's going to happen here. So let's just go ahead and do this one all separately. So this one here is going to cancel. That's an x to the 1. That's going to cancel to an x to the 1 because we subtract, or just x. And there's nothing to subtract here, so we get an x, y squared. Minus, what happened down here? That one canceled to a 1. Okay, minus, what's going on here? Well, the x cancels with the x, so basically it just goes to 0. They both cancel, or they both cancel to a 1 technically. And then you get a y. That's a 1 down there. And then what happens here? Well, this is where you get something. So negative sign. And you can't do anything here. Look, I can't cancel my x and my y, so that's just going to be a y up there and a y down there. A y there and a y there. Okay. All right. So now what do we do? Well, this isn't really in a good format. Okay. So what's going on? Oh, I'm sorry. I messed that up. That should be an X down there. Sorry about that. This is not really in a good format. Why not? Because this one is over 1, and this one is over 1, but this one is over X. So what do we want to do here? Let's just rewrite that. So xy squared over 1, we don't need that, minus y over 1, we don't need that, minus, we do need it here, y over x. This would be your answer. You can't put an x over, you can't do that because there's not an x there. It canceled, remember? So those are 1s. So this term would have no fraction. This term would have no fraction, but this term would still have a fraction in it. Okay, and so that happens sometimes when you can't do anything, you end up with a fraction on the bottom. So each term is now being treated separately, just like we treated it separately here, treated it separately here, treated it separately here. We're going to do the same thing in our answer, and we're going to have 3 distinct answers. Some may have fractions, some may not have fractions. Okay, let's do one more. This is so fun, right? You guys are having a great time. All right, so now we're just going to take our, I know you're not having fun, okay? I know. Okay, I'm having fun. We're going to take our denominator and we're going to put 3y squared, and then we're going to divide this one in 3y squared. Notice the denominator doesn't change. The denominator stays the same in all of them. You can't just randomly change the denominator, so it's got to be the same in all. Now we just take them piece by piece, and I don't have much room up here, so I'll do this one underneath. I'll put it in green. And so we're going to cancel here, and that's going to cancel to a 9, and so we're going to get a 9. And then this cancels to 7 minus 2. This is going to cancel to a 5, y to the 5th. So that'll be y to the 5th. Notice this canceled to nothing, so I'm just not going to put it over anything. Okay. Now, this next one might have a fraction, but this first one didn't have a fraction, so I'm just not going to put it over anything because everything down here canceled out to a 1. All right, so we keep the minus sign, and this is going to cancel to a 1, that's going to cancel to a 6, this is going to cancel to a 1, 4 minus 2 is going to cancel to a y2. So 6y squared plus sign. And again here, we might end up with a fraction. The first two, we didn't end up with a fraction, but maybe we will in this one. 1, 3. Oh, look here. We have the bigger one in the bottom, so this is going to be y1 down here, or just y. Okay, so we have 3 over y. 3 over y, and that would be our answer. Okay. So if it stays in the bottom, leave it in the bottom. If it stays in the top, leave it in the top. If everything in the denominator cancels, you don't have to write a denominator. You don't need to write that over 1, and you don't need to write that over 1. Can you write it over 1? Sure, no problem. I'm not going to mark it wrong. It's senseless to do it. You don't need it. So just get rid of it. That's probably the best way to do it right there, is just to get rid of it as you go through. You don't even need to write it if it's over 1. Okay. All right. Well, that's really all I have for you. You might want to go back and watch that again, kind of in slow motion, because maybe you missed something there. Try some of those practice problems, see how you do. Come back to the video if you're struggling, watch it again, and learn this concept so that you can understand it going forward, and you can add to it as we continue in algebra. Okay? All right. You guys have a good rest of the day. We'll see you later. Bye-bye.